Hello friends, so today in this video we're gonna start a new series in which I will be posting somewhat easy to medium problems from Hackerrank, so that newbies in which they just started competitive coding and they want to learn competitive coding, solve little bit easy problems, so they will take this staircase and it will eventually help them to reach a moderate level in solving competitive programming problems. So this series is only helpful for those students who are just like a newbie in competitive coding. They do not know like hard problems, so we don't go to the hard problems, we just start from the very basic problems, okay, and then we're gonna move eventually to like hard problems also. So we're gonna start and I will post around like 4 to 5 problems in which I will be combining a lot of easy problems. Then we'll move to hard problems and medium problems from Hackerrank, because according to me, if you are just a beginner, just start from Hackerrank from a very basic level and then move to lead code and code forces, just for brushing up your knowledge. Just solve the all easy problems from Hackerrank in just like in 1 week, and then you are good to go to start to moving to higher levels. So let's start solving out these 3 problems in this video: the very big sum, diagonal difference, and plus minus. And I will also post similar videos in which I will be like crunching down 4 to 5 problems or 3 problems in a single video, so that I can just make like few videos and you can get as much information and knowledge from these videos. So if you are at an intermediate level and if you are good at solving code forces problem, you don't need to watch this video, okay? The first problem is very easy. It's just state that I have just like used this problem to make you understand that always try to look at the constraints. In the start, we do not like think that constraints are important, but eventually after we reach a certain mindset in competitive programming problems, like solving those problems out, you have to understand that seeing the constraint is also important to find out what is the time complexity you should need to solve the problem out, and what is the data structure or the data type you should use. Because as you can see, eventually like in general problems, when we add the like different numbers, we use integer, okay, but as you can see in this, like the array I which is given to you, so the problem is very simple. It's just state that you are given n and different numbers, and what you have to do here is you just have to add all these numbers and return the output, which is very simple, like just add all the numbers. But the main thing in this problem is, because a number can reach up to 10 to the power 10, okay, now if you use integer, then will cause a overflow. In overflow means that because every data type, like as an integer, has specific memory which it can store. Now if the number becomes very large, it cannot store that number, and thus you have to use a larger data type. Now what I mean by larger is, instead of using int, you can use a long or a long, okay. Now if you can use this in an integer, roughly 10 to the power 9, if a number is less than equal to 10 to the power 9, roughly it is like 2 into 10 to the power 9. You can look into like you can search it out, but roughly if it up to 2 into 10 to the power 9, which means that if there is some number, if there is some number which has 9 zeros, okay, then at most like around that number you can store in AR. Now if you use that same integer, as you can see, the number is already 10 to the power 10, and just like use the constraints to find out the worst time, like the worst condition happened. The worst condition is you have 10 numbers and all numbers are 10 to the power 10. In that case, the summation will be 10 to the power 10 times, so 10 to the power 11. That's the sum, and you cannot store that sum into integer, so you have to use long or long, whatever. So the problem is now become very simple. So you have to understand that what data structure or data type you have to use according to the constraint. So as you can see, now the problem is very simple. You have to use a vector which has long. So in this problem, you have to just write down this function, okay. So it has only long. So what you'll do, you will make a data type or a variable which will store a total sum, which is also a data type long. Now this is the length of the array. Because I'm using C++, just to find out the length, this is the input array which is given to me. In C++, generally vectors are used. Vectors is some sort of an array only, in which if you want to find out the length of that array, you have to just use ar.size, the size of that array, okay. You can also use length, but size is better. Now what you can do, you can iterate over the array from left to right and just keep on adding the ith element to total and just return out the total. So the problem is very simple. It's not too hard to implement. You just have to add all the numbers out. But the main crux in this problem is understanding the constraints. The second problem is you are given a square matrix and you have to find out the absolute difference between their diagonals. Now, diagonal being by this number 159 and the other diagonal is 359. Now, because it is square, you just find out one dimension, and like if it is length n, then the other length is also n. This is the one observation because it is a square matrix. Now, how we can iterate over diagonals? Now, or like how? So as you can see, in such type of problem, you just have to understand that what are the indexes of the blocks I have to iterate. By indexes I mean because it is a 2D matrix. A 2D matrix has different indexes. Okay, every block can be represented by different indexes. So I will tell you that. So 1 2 3 4 5 1 2 3 4 5. Now this is 0 comma 0, which means 0th row and 0th column. Now this is 0th row, first column, 0 comma 1, then 0 comma 2, and so on. Now if you go to this is 1 comma 0 because it is now in the first row and the 0th column. So 1 comma 1 and so on. Now what you can observe here is if you go along this diagonal, this is 0 comma 0, then this is 1 comma 1, this will be 2 comma 2. So both the indexes, the x and the y, are same along the index or like along the diagonal which is going from top left to the bottom right. Okay. Now if you want to go along this diagonal, what you can observe here is this is the first row, last column. This is the first row, second last column. The first row, third last column. So if you know, so as you can see, if you know the like the index of this, if you know, so if you write a for loop for this diagonal, let's assume I go from I equal to 0 till I equal to n, because the indexes can be 0, 1, 2, 3. So if you want to add all of them, you can use just total plus equal to like a of, if this is a, I. Okay. Now if you want to iterate over this diagonal, then you can do the same for loop, I comma I from 0 till n. But now if you want to add this, like maybe the other variable is t1, you want to add this a, then what you can see here is the first is I, because you are iterating for, like as you can see, for the first I equals 0, then you are on the first row, second row, third row. So this is going right, but for the column part you are on the last column. The last column is n minus 1, and then each step you have to decrease the column. So this is increasing. So if you, like as you can see, if you add this out, what I'm actually trying to explain is in each step this I will increment, like I will go from 0, 1, 2, 3, 4. Okay. Now if it go from 0 till 1, 2, 3, 4, now in the first step, in the first iteration, I will be 0. So this is 0, and the column will be, because this is 0, it is n minus 1 column. Okay. Now in the second step, I will become equal to 1. So now we come to go to the second row. Now because we go to the second row, this will become 1, and now because n minus 1 is the last column index, we add 1 to it. Okay. Oh sorry, I have to subtract it out. If I subtract out 1 from it, it will go to this column. See, this column index, if we subtract n minus 1 I times it, like this will also go from right to left, and also I'm going from top to bottom. So this I is eventually helping me to like find out on which block I am. So I hope you get the point. So we have to just write down 2 for loops eventually, and then we can use that. So I will also help you understand that the first problem, the time complexity is O of n, because we are iterating over from top to like left to right. Okay. In this problem also, for each loop, it is having a time complexity of O of n only. N means the length of the like n is the length of the diagonal. Okay, because what is the length? So as you can see, the same function I've written here. If you first find out the length of the diagonal, which is arr.size, then there are two diagonals variable. We have to store the sum of the diagonal values, so diagonal 1 and diagonal 2. Iterate from 0 till n. The first diagonal value is just arr I and I, and the second diagonal value is arr I, then n minus 1 minus I. So it's just the same thing. And then the output is absolute difference between the diagonal 1 and diagonal 2 value. So we have to just do the absolute difference. I hope you understand this part also. So this for loop is going in O of n, and this is also going in O of n. So the total is O of n plus O of n. It is 2 of O n, but like 2 is neglected out because it is constant. So the total time complexity is O of n only for this program. Okay. Now the third problem. The third problem is not too difficult, but I have to explain you one concept. That's why I've taken this problem also. So as you can see in this problem, you are given an array which is having different integers. Now you have to calculate the ratio of its element that are positive, negative and 0. What I mean by this is you have different numbers and you have to just tell that, count out how many positive numbers are there, negative numbers are there, and how many zeros are there, and then find out the ratio. So as you can see, there are 2 positive, 2 negative and 1 0. So the ratios are total 5 elements are there, to 2 by 5, 2 by 5 and 1 by 5. Okay, so the problem is very simple. You just count out the total number of positive, negative and zeros and just divide them out. But the thing is, you have to output the number in a given precision level. Precision level by means is like you have to output the number up to 6 decimal place. Now they have like mentioned to you that you have to output in a 6 decimal place, but maybe some problem is asking you for 12 decimal places or like 3 decimal places, whatever. So how you can set your precision level for any problem, that's I'm going to tell you. So the problem is very simple. You can just count out how many negative, positive and zeros are there, iterate over from left to right. If the number is positive, you just check that whether the current ith element is greater than 0, so it is positive. If it is less than 0, it's negative, and if it is not greater than 0, not less than 0, so obviously it is 0, so increment 0. So this is the for loop which is running in O of n and finding out total length. Now in the end, when you are outputting the problem, the solution, in this you have to output the answer. Okay, when you're outputting the answer, when you're outputting cout, just before cout outputting your answer, you just write a function which is set precision. This, and just write down the precision level you want after the 0, like after the number. So it is like after point, how many decimal places you want. So I want 6 decimal places. So I just write down this value, set precision, and that will eventually help me to output the value up to 6 decimal places. If I just increase this, it will increase the value. And now can I just divide down these two values and the answer will be this? No. Also remember that, as you can see, I have incremented, I have counted out the total numbers in integer. This is integer, and I will be dividing n. So let's assume that I know that my total number of positive numbers are 2 and the total number are 5. So 2 divided by 5, because the 2 is also integer and 5, the total length of that array is also 5, like integer. So integer divided by integer will always give you an integer only. So that will cause you a problem, because if you get an integer, even if you have set precision level, it will be like, so 2 divided by 5, it will be equal to 0. And now if you want set precision, it will be 0.000 up to 6 position. So answer will be 0 inch. I hope you get the point. So before dividing two numbers, if you want that number to be into a double form or float form, because I want to convert them, it should be having some decimal places value, typecast that. So if you have a numerator and denominator, instead of like doing anything hustle bustle, what you can do here is just typecast any of the variable, the numerator or denominator, to double, like anything. So as you can see, now I have typecasted. So for typecasting, just write down the data type in which you want to typecast that particular variable in front of that. So I write down double in front of positive and then just divide down by n. So this will first typecast this positive integer, or like this positive number, like the count of the positive numbers in the array, to double. Now because I'm dividing double by an integer, it will eventually give me a double, and because I get a double value, it will having a set precision level of 6 decimals. And you have to do the same for positive, negative and zeros. Remember, that's why I'm using double. If I do not use double, the answer will be, all of them will be 0, like 0.000 for every number, because I hope you get the point, because everything is in integer. Okay, so I hope you understand the logic and the code for all the 3 problems. If you have any doubts, you can mention down in the comment box. I will try to help you as early as possible. You can also join my Telegram channel, and if you haven't subscribed my channel, you can subscribe that also.